Okay, so this video is going to look at how to graph an equation in two variables. And of course, by in two variables, we mean with two variables or having two variables. And we're going to, in particular, be looking at graphing by plotting points. So the first thing you need to be able to do to graph by point plotting is to find solutions to an equation in two variables. So what is a solution to an equation in two variables? A solution to an equation in two variables is an ordered pair that makes the equation true. And usually we assume that the first coordinate is getting substituted for the variable x, and the second coordinate is getting substituted for the variable y, but there are situations where that's not the case. So let's look at a couple examples. Let's look at 4, 2. Now 4, 2 is or is not a solution of y equals x squared. Well, here our variables are x and y, and we haven't specified which is 4 and which is 2. So we just assume that the first one is x and the second one is y. So we substitute 2 everywhere we see y in the equation, and 4 everywhere we see x in the equation, and ask, is this statement true? And in fact, this statement is false. So we see that 4, 2 is not a solution to y equals x squared. And now for an example where we have variables other than x and y. So we're going to use p and q, and we're going to ask, is pq equals 3, 9 a solution of the equation q equals p squared? Now again, it's important to substitute the right number for the right variable. When we defined this point pq equals 3, 9, we are specifying that 3 is the value for p and 9 is the value for q. So here we substitute 9 everywhere we see q and 3 everywhere we see p. 9 equals 3 squared. Is that true? Well, yes. Yes, it is. So this ordered pair makes this true. And pq equals 3, 9 is a solution to q equals p squared. So that's how you determine whether an ordered pair is a solution to an equation in two variables. But what if you just want to find a solution given an equation? So for example, y equals x squared plus 1. So we want an ordered pair that'll make this true. So an ordered pair is going to consist of a value for x and a value for y, such that y is equal to x squared plus 1. And so what we're going to do is we're just going to pick a value for one of our variables. I'm going to choose 1 for x. How did I figure out to use 1? I picked. There's no magic. X is 1 because I say x is 1. You could use any number for either variable. Well, when x is 1, if this is going to be true, then what has to happen to y? Well, I substitute the 1 in for x and see that y has to be 2. So choosing x equals 1 and solving for y gives us the solution 1, 2. So how do you find a solution to an equation in two variables? You substitute a value that's just chosen by you, and you substitute it in for one of the variables, and then you solve the resulting equation in one variable to get the value for the other variable. Now, I've said you get to choose the value you substitute and which variable you substitute it for. Can you really use any number for either variable? And the answer is kind of yes and kind of no. Most values you choose for either variable will give you a valid solution. But it is certainly true that some choices are better and easier to work with than others. Because remember, you're finding these solutions with the goal of being able to graph them. And also you want them to be as easy to calculate as possible. Say instead of x equals 1, I plug in y equals 7. I would substitute 7 for y and get 7 equals x squared plus 1. And I can solve this for y. This becomes x squared equals 6, or x is the square root of 6. And this actually has two solutions. One where we take the positive root and the other where we take the negative root. And we see that here we now have solutions positive root 6, 7, and the negative square root of 6, 7 are both solutions. So these are perfectly valid solutions, but they're maybe not the easiest things in the world to graph, and they were more difficult to calculate. So yes, you can plug in most values for either variable, but some choices are better than others. For example, with y equals x squared plus 1, I would plug in values for x, because then you just have to evaluate. You don't have to really solve an equation. So another possible example is 2x plus 3y equals 6. Good choices for substitutions here are even numbers for y and multiples of 3 for x. Why are these a good idea? Well, let's look at an even number for y. So let's look at 4 for y. When y equals 4, this becomes 2x plus 3 times 4 equals 6, or 2x plus 12 equals 6. 2x is negative 6 and x is negative 3. And we come up with a nice ordered pair where both the x and y coordinate are integer numbers, so they don't have a decimal or fraction part, and they're very easy to graph. And the reason this works is because we note that 6 is even, so if we plug in an even number for y, 3y is even. We're going to subtract off the 3y. We've got an even number minus an even number. This is still even. And then when we divide by 2, an even number divided by 2 is an integer number. So that's why even numbers are good choices for y. To see why multiples of 3 are good choices for x in this situation, you use similar logic. Now let's use this to graph our y equals x squared plus 1. We found 3 solutions, so let's go ahead and graph them on our Cartesian coordinate system. We've got 1, 2. We've got square root of 6, 7. And square root of 6 is somewhere between 2 and 3. We go up to 7. So here we have square root of 6, 7. Here we have 1, 2. We have negative square root of 6, 7. Up here. So does this really give a clear shape? Not really. We maybe want to try to figure out what's going on around here in the 0, -1 range. So let's go ahead and see what happens at 0, at -1. When x equals 0, y equals, well, 0 squared plus 1 is 1. So we've got the point 0, 1, which is here. And when x is negative 1, we've got y equals negative 1 squared plus 1, which is 2. So we've got negative 1, 2. And this gives us a bit clearer idea of what is going on. It comes down like so through the point 0, 1, and then it goes back up. So the rough sketch looks something like this. So just to recap, how do you graph an equation in two variables? By plotting points. You find a solution, you plot the solution, and you just keep doing that until you can tell what shape the graph is falling into. How many points do you need? It depends. If you recognize the graph is a line, you only need 2. If you recognize that the graph has certain types of symmetry, which we'll talk about later, it can make it where you need fewer points. But you need enough points that you can tell what the shape of the graph is going to be. And that is graphing by plotting points.